Hold up.
Huh?
What's a PDT?
Many hockey analysts use what's called a PDT.
PDT stands for a probability distribution table, and it's a table that lists all possible outcomes of a discrete random variable and their corresponding probabilities, which shows how likely each result is with the crucial rule that all probabilities must sum to 1. Since our question is related to hockey, Mason's going to give a little bit of background information on the sport and just some general information.
The NHL was created in 1914, starting with 6 teams. The sport of hockey was created in the 1800s by the Canadians with inspiration from the British sport banty. The game itself is made up of 3 20-minute periods with an overtime tiebreaker if necessary. In the game, 2 teams face off, composed of 20 skaters and 2 of the weirdest guys on the ice. Too weird to be skaters themselves, the goalies. In your standard 3-period hockey game, the goalie gets on average 10 shots a period, and to have a good save percentage, saves on average 9 of those 10 shots, totaling about 30 shots and 27 saves a game.
All right, so part A of this question is asking for us to create a PDT table. So first, we're going to do x over p, and then for our x values, we're going to do 8, 9, and 10. And since the goalie saves an average of 9 of those 10 shots, we are going to make sure that the 9 has the biggest p-value, as well as the p-values all adding up to 1, and then that should complete part A. All right, for part B of the question, we need to find the mean, variance, and standard deviation. So for the formula for mean, we are going to do x1 multiplied by p1 plus x2 multiplied by p2, and you would do that for all of the x and p values in that table. So in this case, we are going to do 8 multiplied by 0.24 plus 9 multiplied by 0.46 plus 10 multiplied by 0.30, and that should give us the mean of 9.06. And to find variance, we do a similar formula, except now we're going to do x, the first value of x squared times p1, and you would add that by the rest of the x and p values. So now it'd be 8 squared times 0.24 plus 9 squared times 0.46 plus 10 squared times 0.30. But you also you subtract all of that by the mean squared. So we would do that minus 9.06 squared, and that will give us the value of 0.5364. And then finally, to find the standard deviation, we just take the variance and square root it, and the standard deviation is going to be 0.7324. And now finally, part C is asking for us to interpret the mean and the standard deviation. So the script for mean, it would be given many trials, the expected number, in this case, the shots per period, it would be 9.06. Now for standard deviation, the script goes the average distance from expected value of our mean, which is 9.06, shots per period is 0.7324, and that is the scripts. And now with parts A, B, and C done, hopefully you have a better understanding of PDT tables and hockey in general.